All right, section 8.4 now deals with scale factors and area. Now, the way scale factors and area work is we're going to see, because usually scale factors, what we've looked at before is scale factors and side lengths, and we just multiply by a certain scale factor. It's going to be a little bit different for area. So what happens to area when we increase the size of an object? Well, let's look. What's the scale factor of the sides? Well, we can see from 2 to 4, it's been enlarged by a factor of 2. So dimensions 3 to 6, enlarged by a factor of 2. The area, 2 times 3 is 6, 4 times 6 is 24. The areas have been increased by 6 to 24, has been multiplied by 4. But 4 is also 2 squared. Be careful with that, and look at that, 2, 2. So the dimensions have been multiplied by 2, the area has been multiplied by 2 squared. Let's see another example. So here I have a circle. Here my radius is 5. Here my radius is 15. I can see that if I'm just looking at straight radius, my dimensions have been multiplied by 3. And if I'm looking at area, remember area of a circle is pi r squared, pi r squared. This circle has an area of 25 pi. I leave it in terms of pi because it's easier to compare. This one has an area of 225 pi. Okay, so my dimensions have been multiplied by 3. My area has been multiplied by 9, which is 3 squared. So dimensions times 3, area times 3 squared. Interesting. So that means whatever the dimensions are increased or decreased by, the area will be increased or decreased, remember, because you can have a reduction, by that value squared. If we're dealing with area, then the value is squared. So dimensions that are increased by a factor of 5, area will be increased by 5 squared, or 25. Dimensions increased by a factor of 1/4, the area will be decreased because it's a reduction of 1/4 squared, or 1 over 16, right? So don't be concerned, oh no, it's a fraction, what do I do? Remember that when you're squaring fractions, you square the top and the bottom, top and the bottom. 1 squared is 1, 4 squared is 16. So it's a reduction because 1/16 is smaller than 1. This is an reduction and increasing, I can't think of the word right now, is increased, so it's a factor of 25, which is bigger than 1. Enlargement and reduction, there we go. Okay, so now let's work backwards. Uh-oh, nobody likes working backwards. So we're going to determine the scale factor used. So here I have the radius. Okay, this is easy, I've done this before, right? The radius from 6 to 24. My scale factor, it's been reduced, right? Whoops, sorry, I'm going the other way. Going actually starting here and going to this one here. It's been reduced by a factor of what? Well, it's been divided by 4, which means my scale factor used is 1 over 4. The other way you could have done that, I guess we could have started the way we did last time, right? 24, sorry. Always start off with my diagram, which is my second one, 6 over 24, which is equal to 1 over 4 if we reduce it, right? Or you can just look to see what's it been divided by and go straight to your scale factor. I know it's been reduced, I know it's going to be a fraction. Now, let's look at example 4. Here I'm given just the areas. This is going to be kind of hard. Well, it's been 15 to 800. Okay, so I know it's an enlargement. What's it an enlargement by? So I have 800 over 15. 800 over 15 is 53.33. Is that my enlargement though? Because I'm dealing with area, right? So when I'm dealing with area, remember that it's that value squared. So I don't know what the side lengths are, but I know it's that value squared. So in order to find out the actual scale factor, I'm going to have to take the square root. I'm going to have to take the square root to figure what my scale factor is, which is 7.3. So for scale factor, if you're given area, you need to take the square root. So my scale factor ends up being the square root of whatever my areas are divided by each other, which ends up being about 7.3. Okay, so for scale factor for areas, if you're trying to find the scale factor, You can't just look at the areas. You have to take the square root because you're trying to figure out what the scale factor is, and usually scale factor is determined by the side lengths, what the side lengths have been increased by. All right, so scale factor based on area, remember that it's squared. Working backwards, it's a little bit more difficult. You have to take the square root. It's just the opposite of whatever it is squared.